Good morning. Today we will learn about data structures in C. Data structure means organization of data in an efficient manner. We know that organization of data is very important when we are dealing with large amount of data. So any operations can be performed easily on a well-organized data. Okay, you can study well if your books are well organized. You can collect books, we can pick books if they are organized in an efficient manner. Same way, if data is organized in a well-organized way, we can efficiently retrieve it and do operations on it. So data structure is a method, is a container for organizing data. Okay. So we learn how do we classify data structure. Data structures are classified into two broad classes. One is primitive and non-primitive. Primitive data type depends on the programming language. They are the fundamental data types which are supported by the programming language. For example, int, float, character, double, etc. in C language. In Python we have bool data structure, bool data type also. So depending upon the programming language, these data types vary. Okay, they are the fundamental data type and they are known as primitive. And second part is non-primitive. That means the data type or data structure which are not primitive. How do we create a non-primitive data structure? We are creating a non-primitive data structure using this primitive data type. Okay, using this primitive data type, we are creating another data structure. They are known as non-primitive. Again, non-primitive data type are classified into two: linear data structure and non-linear data structure. If the data is organized in a sequential manner, then it is called linear data structure. For example, arrays, list or linked list, stacks, and queues. Similarly, if the data is arranged in a random order, it is called non-linear data structure. For example, trees, graphs, tables, sets, dictionaries, heaps, etc. Okay. This is a diagram of data structure, classification of data structures. We have primitive, non-primitive. Inside primitive, we have integer, character, float, double, etc. In the case of non-primitive, we have linear and non-linear. Linear means that grows in linear direction. Non-linear means the one which grows in random direction. Okay. So this figure shows the difference between linear data structure and non-linear data structure. In the case of linear data structure, data is arranged in a linear fashion in which the elements are linked one after another. After the first one, second one is linked. After the second one, third one is linked, etc. The one linear data structure which you are familiar is array. Array 0, array index 0, index 1, index 2, 3, 4, etc. So in that way, the elements are arranged. Here we can traverse all elements at a stretch. At one stretch, we can access all the elements. But at a time, only one element is directly reachable. Using a for loop, we can read all elements in an array. For I equal to 0, I less than and I plus plus, scanf, percentage, and I, or printf AI. So in using one for loop, we can write elements into the array or read elements from the array. But at the time, we are accessing only one element, right? And AI and A0 and A1, etc. We are not taking every element in one stretch. We are accessing elements one after another. Okay, that's the case with linear data structure. Here, one of the disadvantages is that it tends to waste memory because in advance we book sufficient memory, wasting unused memory. But it is very easy to implement. We have learned what an array is. We have learned queue, stack, linked list, etc. in the category of linear data structure. In contrast, this we'll see what is a non-linear data structure. Here, data elements are not linear, but they are hierarchically related. Do you remember the diagram which I have shown previous? This is a hierarchy. This is a hierarchy. This is the first one in the hierarchy. Data structure is the first in the hierarchy. Then we have primitive, non-primitive, int, character, float, etc. There's a structure. There's a hierarchy structure. This diagram is known as a tree. Okay, this is a tree. What does that mean? It looks like an uprooted tree. This is a root one, two branches. The primitive data structure has four branches. Linear has again four branches. Non-primitive has two branches. Non-linear has two branches, etc. So the direction of growth is not same. Okay. Sometimes we have more branches. Sometimes we have less branches. Just like a tree, we cannot predict how many branches a stem has. Such type of structure is known as non-linear data structure. Here we cannot see. Here all data elements cannot be traversed in one go, as the nodes are not visited sequentially. We are not visiting nodes sequentially. It is visiting nodes. We are visiting the nodes randomly. But memory utilization is very efficient here. Okay. Implementation of non-linear data structure is complex. In this category, we have trees and graphs. Now we'll learn another concept known as abstract data types. You know what a data type is. You have learned what a data type is. You have learned about fundamental data types or primitive data types. That depends on the programming language. Okay, in float character, etc. That depends on the programming language. But in the case of abstract data type, it is a theoretical concept. We design a structure and try to implement that structure using a programming language. Okay, so ADT or abstract data type is a mathematical model for data type where a data type is defined by its behavior from the point of view of a user, specifically in terms of possible values, possible operations on that value, and behavior of those operations. Okay, we will learn. We can understand this concept better when we learn an abstract data type. Okay. Here we have a data values and associated operations that precisely define this ADT. It is a specification of a set of data and set of operations that can be performed on the data. How can we make an ADT? It is made up of primitive data type only because the programming language supports only primitive data type. So all other data types are created using this primitive data type. But the idea of creating ADT depends on the model. We can design a model, and the model is implemented using a programming language. Examples of ADT are stack, queue, tree, etc. are all examples of ADT. Okay, this is the operations of an ADT. It will not be clear to you now, but once we learn stack and queue, this will be clear. But just let me complete this. Stack is an ADT. The operations are which whether stack is full, stack is empty. You can insert element to the stack, pop an element from the stack, check whether what is the top of the element, what is the size. In the case of queue, we can also check operations like whether the queue is full, empty, insert, delete, etc. We'll revisit this slide again after completing stack and queue. For the ADT list, the operations are size of the list, insert into the list, remove from the list, get an element at position I, replace X with the value Y, etc. Okay, now let's see what an algorithm is. You have learned what an algorithm is. What is an algorithm? It's a set of well-defined instructions in a sequence to solve a problem. We want to solve a problem. So we have to give a set of instructions to solve this problem. That's what an algorithm is. So we can write algorithm in many different ways. Here in this semester, we are not going to learn what an algorithm is or how do we write an algorithm, but in which way we can write a good algorithm. We'll analyze an algorithm. We'll say what are the qualities of a good algorithm. Okay. Input output should be defined precisely in the case of algorithm. Each step of algorithm should be clear. It should be very clear. It should be unambiguous. There should not be any confusion in writing. So by reading a statement, the machine should be able to understand what it is meant there. Okay. It should be most effective among many other ways to solve a problem. So in order to solve a problem, we have many other ways. But here, what do you have to do? We have to write an efficient algorithm. Our algorithm should be the best among other alternatives. Okay. In the case of algorithm, we shouldn't write any computer code. Instead, the algorithm should be written in such a way that it can be used in different programming languages. So if you write an algorithm that can be implemented using any primitive data type in any programming language. Okay. Needing the primitive data type, using a programming language, you should be able to complete that algorithm. You should be able to program the algorithm. Now see some of the aspects of analyzing algorithm. Two important ones are time complexity and space complexity. What's time complexity? That means how many time an algorithm is taking to complete. Space means how many space is required to implement this algorithm. When we are implementing in this algorithm, how many bytes, how many megabytes is required to run this. Okay. An algorithm is analyzed to identify its performance and choose the best one to solve a particular problem. Time complexity of an algorithm quantifies the amount of time taken by an algorithm to run as a function of the length of the input. Okay, that means time complexity defines the amount of time taken by the algorithm to run as a function of length of the input. What does that mean? That is, every algorithm is a function of its length of its input. Suppose we are writing algorithm. We are writing a program to find the sum of n numbers. Okay. When the n equal to 10, if you compute the time will be around 2 seconds. But if the n is 1000, the time will be around 5 seconds. Okay. If the n is 10 lakh, the time will be around 1 minute or 2 minutes like that. So the time grows depending upon the length of the input. So when we are comparing the algorithm, it should be with the same number of n. Okay, so the time complexity of an algorithm quantifies the amount of time taken by the algorithm to run as a function of the length of the input. Similarly, for space complexity of an algorithm, it quantifies the amount of space or memory taken by an algorithm to run as a function of the length of the input. The same definition, in the case of time complexity, we are quantifying the time. In the case of space complexity, we are quantifying the space or memory taken by an algorithm to run. Here also, the space depends on the length of the input. Same way, if we are running a program for 10 input, we need only space to store these 10 elements. If you are running it for 10 lakh input, we need the space to store all the 10 lakh inputs. So depending upon, we can analyze the time as well as space taken. Here, the time complexity and space complexity depends on lot of things such as hardware, the operating system, processors, etc. But while analyzing, when we are trying to analyze, we consider only its execution time and space factor. Okay. If you write a very complex routine and if you run in a very good hardware, it will come out successfully in few amount of time. But we are not analyzing there. We are analyzing, that is, we are fixing the hardware, OS, processor, etc. constant and try to analyze the algorithm using the same background, same counter background. We try to analyze that. Okay, we compute the execution time, how many time it will take in order of n, order of the number of inputs. Next is another concept which is known as order of growth. Order of growth is how the time of execution depends on the length of the input. Order of growth will help us to compute the running time with ease. We ignore the lower term because lower terms are insignificant for the large input. We use different notation to describe the limiting behavior of a function. Okay, I'll just tell you what is order of growth. Just one second ago, I have told you about the number of inputs. For smaller input, the time will be less. For larger input, the time will be more. The order of growth means how our algorithm is growing if we are increasing the number of inputs. How our algorithm is performing when we are increasing the number of inputs to 1 lakh, 2 lakh, etc. What's the growth? Okay. So there are three different terms for representing these time and space complexity. One is O notation, big O notation. Second one is omega notation. And third one is theta notation. Omega is a set of functions that grow slower than or at the same rate as the expression. It indicates a maximum required by an algorithm for all input values. It represents the worst case complexity of an algorithm. What does that mean? I can say that suppose my algorithm will take 10 seconds. This is the worst case time. My algorithm will not take more than 10 seconds under any circumstance. That's the worst case complexity. That is represented in big O notation. That is, my algorithm will take a time maximum 10 seconds. That's known as order notation. Second one is omega notation. I'll just read it out. Is a set of functions that grow faster than or at the same rate as the expression. It indicates that the minimum time required by an algorithm for all input cases. What is it? What is that? It is a best case complexity. The minimum time 1 second. In best case, my algorithm will perform minimum 1 second. So I cannot run it lesser than this. For any cases, minimum it will take 1 second. That notation is known as omega notation. Okay. Third one is theta notation. Theta is a combination of both. As we are telling that my algorithm lies in theta. It consists of all functions that lie in both omega and O notation. Or in another word, this represents the average time of the algorithm. Average case time of an algorithm. In average, the time is 5 seconds. Okay. It is not the best case, it is not the best worst case, but on average, it will take only 5 seconds. Is that clear? We have learned about time complexity. Here, we have specified only time. The same thing is applicable in the case of space complexity also. We can specify the minimum space, maximum space, and average space. Okay. Now see how can you measure the space complexity. Space complexity is a measure of the amount of working storage of an algorithm needs. It means how much memory in worst case is needed at any point in an algorithm. As with time complexity, we are mostly concerned with how the space needs to grow, big O terms, omega terms, as well as theta terms. Look here. Here we have a function int sum, int x, int y, int z. Int r equal to x plus y plus z. Return r. Okay. How many spaces required? We need to store x, right? X is an integer. We need a space for x. Similarly, we need a space for y. We need a space for z. Then we need r to store x plus y plus z. This is a space requirement. Okay. So 3 unit of space for parameters x, y, z. 3 unit of space for the parameter x, y, z. And 1 unit space for the local variable r. Okay. So altogether 4 unit of space. These are all integers. So 4 into 2 equal to 8. 8 bytes are required for this program to run. So this is, if we increase the number of inputs, will it change? Suppose I'm running this program for 3 input. I mean, if you change the value of n, number of inputs, we are going here. This is a program to find the sum of 3 inputs. So there is no n here. Or we can say that this is fixed. That is, we have our order is order of 1. This will be computed in order of 1. There's fixed amount of time. It doesn't not grow with n. Okay. Look at the second one. Some int a array int n int r equal to 0. For int I equal to 0, I less than n plus plus I, r equal to r plus ai. Return r. What this program is doing? It is finding out the sum of n elements. So if you have 3 elements, what will it do? It will add these 3 elements. If you have 4 elements, it will add those 4 elements. This changes with the value of n, right? So how many spaces required? Here we need space for a, the number of elements in a, n, r, 2 local variables, 1 parameter n, 1 local variable r, and size for a. What is the value? What is the size of a? The size of a depends on n. If n equal to 5, the size a will be 5. If n equal to 10, a will be 10. Okay. So altogether it will take n plus 2, right? n equal to 5 plus 2 for storing n as well as r. So we can say that it takes time n plus 2. So we can say that order of n. This 2 is not significant. N plus 2, n minus 2, we are not considering. We are not considering this lower terms. N plus 5, n plus 10 doesn't matter. N plus n is 2n. Okay, n plus n minus 1, it is in the order of 2n. Okay? Otherwise, it's the order of n. Okay. So if you write n plus 5, it is order of n. If you write n plus n, it is 2n. That is 4. Again, order of n. 2 times n. Okay, these are all order of n. But we write n into n square. We can say write that order of n square. Similarly, order of n cube, order of 2 to the power of n, order of log n, etc. Look at this diagram. The diagram shows the rate of growth of common computing time functions. Order of 1, what does it mean? The time is constant. It is not growing. For every time, it will take constant amount of time. Next is order of log n. Order of n, order of n log n, order of n square, order of n square log n cube, 2 raised to n factorial, etc. This is the diagram for this. You may be remembering this. This is n. It grows with n. When n equal to 4, the answer is 4. N equal to 16, answer is 16. N equal to 32, answer is 32. N equal to 128, answer will be 120. That is order of n. Order of n square, what does it mean? When n equal to 1, 1 square is 1. N equal to 2, it will be 4. N equal to 4, it will be 16. N equal to 8, it will be 64, like that. In the case of n cube, n equal to 1, answer is 1. 2, for 2, the answer is 8. For 4, 4 into 4 into 4. That's why it grows. Okay, this is how the algorithm looks like. So what you have to take care of this, log n is smaller than n. N log n is again smaller than n square. N cube is greater than n square. 2 raised to n is going like this, just like exponential way, going up. Okay, it's enough for this section. Thank you. I'm stopping here. Stop presenting.